Earth-observing satellite for Maxar, launched by SpaceX. Also, learn a bit more on the Falcon rocket.
5, 4, 3, 2, 1. Liftoff. Go Maxar, go Falcon.
Vehicle is pitching downrange.
So in case you are just joining us, we are 32 seconds and counting, and Falcon 9 has successfully lifted off from Launch Complex 39A at Kennedy Space Center, carrying 2 Worldview Legion satellites for Maxar intelligence. In just a few seconds, we'll throttle the
Power
engine.
and telemetry nominal.
Confirmation there that everything's on the right track. And right now we're preparing to throttle the engines down ahead of max Q, or the period of maximum aerodynamic pressure on the rocket.
Falcon 9 is supersonic.
With that call out, we know that Falcon 9 is moving faster than the speed of sound.
Max Q.
And there's confirmation of max Q. Now, during ascent, we tilt the engines. The technical term for this is called gimbaling, and that turns the rocket horizontally in what we call a gravity turn. Right now, the rocket is still going up, but we're also heading horizontally away from the launch pad. There's confirmation of MVAC chill on board our second stage. Now, our rocket needs to go about 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and reach orbit. You can keep an eye on that stage 1 telemetry in the bottom of your screen as we move toward that target insertion speed. Next, we'll have several events coming up in quick succession, and we should hear and see all of those called out by Mission Control, starting with main engine cutoff, or MECO, then stage separation, SES-1, first stage boost back burn, and fairing separation. MECO is where we will shut down all 9 M1D engines on board the first stage, followed quickly thereafter by stage separation, when the first and second stages of Falcon 9 separate from one another, and then we'll turn on
Main
the
engine cutoff.
MVAC engine
Stage
for the first
separation
time.
confirmed.
MVAC ignition.
Stage 1 boost back startup.
So we have great views on your screen right now, and confirmation from Mission Control that we've had MECO, Stage SEP, and SES-1. We also heard the call out, and on the left-hand side of your screen, we have great views of our boost back burn, which is what's currently putting the booster on a trajectory to head back toward Earth and touch down at landing zone 1. Next up, the fairing will jettison away from the second stage, as it's no longer needed now that we're in space, and the payloads no longer need that aerothermal protection.
Fairing separation confirmed.
Right on schedule. Those fairing halves are now headed back to Earth to be recovered by our ocean recovery ship, Bob.
Stage 1 boost back shutdown.
Now, at just about T plus 3.5 minutes into today's mission, the next major milestone we're standing by for is our first stage entry burn. Getting some great views on the left-hand side of your screen of that grid fin deployment right now, too. Those hypersonic grid fins are the primary mechanical mechanism by which we steer the rocket on its way back to Earth.
Nominal trajectories.
Nominal trajectories there for both our first and second stages, while stage 2 is on its way to orbit to deploy 2 Worldview Legion satellites for our customer Maxar intelligence. To start the entry burn at about T plus 6 minutes, we'll relight the 3 of the M1D engines on board stage 1, starting with the center engine, known as E9, followed shortly after by E1 and E5, which is similar to pumping the brakes to slow down the vehicle as it passes back into the Earth's atmosphere. We need to slow down to reduce re-entry forces, which then helps us to recover and reuse that first stage. During the entry burn, Falcon 9 is decelerating by firing those Merlin engines, but we're still moving really fast. This causes the vehicle to fly through Merlin's exhaust gases. Great views of it on your screen there right now. Those exhaust gases are also known as the rocket's plume. That in turn deposits a layer of soot on the vehicle surface. The soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle, giving it that flight-proven look. We are standing by with these incredible tracking shots for that entry burn begin at T plus 6 minutes and 11 seconds. Of course, reusability is key to lowering the cost of spaceflight, which enables more investments in critical scientific research. The Falcon 9 first stage supporting today's mission is about to perform this entry burn for the 4th time. And of course, meanwhile, up in space, our stage 2 continues to look good, and we'll keep bringing you those MVAC engine views as we have them.
Stage 1 entry burn startup. Stage 1 entry burn shutdown.
And
Stage
confirmation
1 FTS is safe.
of entry burn shutdown. The engines on board the first and second stage are actually pretty similar. They're just optimized differently. The Merlins on the first stage are optimized for sea level, and these achieve 190,000 pounds of thrust each during both ascent and descent. At liftoff, Falcon 9's first stage has thrust greater than 5 747 airplanes at full power. The MVAC engine, which
Nominal
we have
trajectories.
a great view of on the right-hand side of your screen, and confirmation there that everything's on a nominal trajectory, has a much wider
Stage
nozzle.
1 transonic.
Wider nozzle allows us to be optimized to 220,500 pounds of thrust in the vacuum of space.
Stage 2 terminal guidance.
Stage 1 landing burn.
Stage 2 FTS is safe.
We're hearing that sonic boom of
Stage
re-entry.
1 landing leg deploy. Stage 1 landing confirmed.
And confirmation that our Falcon 9
MVAC
booster
shutdown.
has touched back down on landing zone 1 at Kennedy Space Center, and that we have had successful MVAC shutdown on board stage 2. This was the 4th launch and landing for this first stage, and this landing marks SpaceX's 404th recovery of a SpaceX orbital class rocket, including
Nominal orbit insertion.
first stage landings for Falcon 9 and Falcon Heavy. And with that confirmation, we also know that stage 2 is on a good orbit up in space.